Hello everyone, in this video I'll be explaining the problem GCND and it was asked in Codechef contest starter 208. So let's read out the problem. So the greatest common non-divisor. So GCD is basically greatest common divisor, but here GCND is basically the greatest common non-divisor of two positive integers x and y satisfying x greater than equals to 5 and y is greater than equals to y. Okay, so x and y is basically greater than equals to 5, denoted GCND x comma y is defined to be the largest positive integer z satisfying the following conditions. So this z is less than equals to x or z is less than equals to y. So here we have our condition. So even like this z, if it is less than one of the two integers, it is fine. It should be, if it is lesser than both two, it is fine, but it shouldn't be greater than both. And the given x should not be a multiple of z and y should not be a multiple of z. So don't worry, I'll be telling you clearly on the board. And it can be proven that as long as x and y are both greater than equals to 5, GCND of x and y always exists. So they have given, like, it can be proven, and they have given. So it is a statement, so we'll have to take this into consideration. So you are given an array A of length n such that the A of I is greater than equals to 5, since they have said like x and y both having greater than equals to 5, so this condition will always satisfy. So that's why in the input they have given uh, the elements are greater than equals to 5 and then less than equals to 10 power 7. So for each I, it is one based indexing. That's why they have said like I is greater than equals to 1, less than equals to n. So your task is to compute the maximum GCND of some two elements of the array, that is across all pairs of indices I and j, where the pair of indices should satisfy this way, like I is greater than equals to 1 should be less than j is should be greater than I and should be less than equals to n. So basically we'll have to take all pairs, and the pair wherein it should not have one element, and you're taking, like, basically let's say I is equal to 2, so both I and j should not be taken as 2 only. One element you can't take, you should take different elements. That is the statement of this particular statement, I mean meaning of this particular statement. So compute the maximum possible value of GCND. Okay, so among all these pairs we'll have to consider the maximum GCND. So it's easy only, don't worry, I'll be telling on the board. So the input format is, we have test cases. For every test case we have a single of integer n, number of length of the array basically, so number of elements in the array, and in the next line we have n elements. Okay, so let's try to understand this. They have given 3 examples. First understand these 2 examples, 2 and 8, 8 and 5. So what we have is, the array length is 2 and elements are 8 comma 5. Let me call it as a. So in the question what they have given is they will give n elements, and these elements all the array elements are greater than equals to 5, less than equals to 10 power 7 and your I will be ranging from 1 to n. It is 1 based indexing. So among these in these elements, right, in this array, you need to take one I and j in such a way that your I should be greater than equals to 1, should be less than j, and j should be greater than I, should be less than equals to n. So let's say you have taken ith a of I as x and a of j as y. So now you'll have to find GCND of these two, greatest common non-divisor of x comma y. So greatest common non-divisor of x comma y, it is defined in this way, like this x you'll have to find greatest common GCND, and which is basically given as z. If you find GCND of x and y, its value is z. So this z should be lesser than equals to x, or it should be lesser than equals to y. So this is the condition they have given, which means the integer what you're getting from the GCND, it should be less, at least lesser than one element, lesser than or equals to one element. Okay, and if this z is greater than both x and y, so that is not a GCD. So this is meaning of this statement. And then the second statement is what again, second statement they've sent is this x and y should not be a multiple of z. X and y both should not be a multiple of z, should not be multiple of z. So meaning of that is you cannot write x in the form of, let's say, x star k, where k being some integer is equals to z, or no, and because both the condition has to be there, x star k, some k1 or k2 you can take, so it should not be equals to z. If not this a, this is y. So I think you are understanding. So if you try to take x and then multiply with some integer, this k1 and k2, k1 comma k2 what I have written, it is some integer, right? From 1 to some infinity. So if that is the case, like x into some integer, if you do, then if you are getting z, which means x is a multiple of that. So it shouldn't be that way. Your k should be, whenever you take z in such a way that it should not be multiple of x and y both. So this is the problem statement that given. And yeah, now what they're asking is the array element whatever they given, you will have to find the pairs, right? So in order to find the pairs, what you can do is you can take two for loops, and this is a brute force way, and this will be giving tail. So I'll be telling you just brute force way. So your I starts from 0 till n minus 2 he'll go, and your j, it will start from I plus 1, because as asked in the question, this j should be greater than I, so that's why I'm starting with I plus 1, and your till your j will go till n minus 1, and some logic I'll be writing here, some logic, this logic will be same. So this logic I'll be explaining you, but this is pretty much how you'll have to find in a brute force way. So now this will give TLE because your n is 10 power 5, so it is a n square time complexity, so it will give 10 power 10, and 10 power 8 is the max allowed operation. This is for 1 second. If your operations are more than that or equals to this also, so you will get TLE. So let's try to get rid of this for loops. So let's understand they're given here, they've given only two integers, so only one pair you can make, right? 8 comma 5. So you will have to find out GCND of 8 comma 5. And one thing I want to highlight here is that if you sort this array, so you will have 5 comma 8 as the array element when you're sorting this, right? So again 5 comma 8 is GCND. Here GCND of 5 comma 8. So GCND of 8 comma 5 and 5 comma 8 both are same only. As like for GCD of 2 comma 3 is 1 only, and GCD of 3 comma 2 is also 1 only. So in the same way, GCD of both elements are same only. So I'll be sorting the array. I'll be telling why I'll be sorting. In this example I'll not be telling, but in the later I'll be telling. So let's try to take GCND of 8 comma 5. How do you find that now? So now let's say we are taking one integer z as 8. When you take z as 8, you have x as, let's say, 8 and y as 5. So your z is not satisfying the condition. Which condition it is not satisfying? So it is saying the first condition is satisfying. This is the first condition, and this is the second condition. First condition is satisfying because z should be lesser than equals to 8. This is correct, as you can see, like z is 8 and this is also 8. This is true, and also the z should be lesser than equals to y. So 8 less than equals to 5 is not false, but one condition is true, so first condition is true. Now in the second condition, if you see, the x should not be multiple of z, right? So if you try to if you try to take z by 8, I mean x, basically x divides z in this case, like z is 8 and x is also 8, 8 by 1, I mean, which means if you take x, okay, since I was telling x into k1 is equals to z, you'll have to find, right? So what is that integer if you'll be finding? So the integer will be k1 is equal to z by x, right? If you happen to find z by x having integer, so which means it is a multiple of I mean, yeah, like x is a multiple of z. So in this case, as you can see, what is k1? As I told you, z by x, it is k1, so it is 8 by 8 1. So k1 you have found one as integer. So obviously 8 into 1, if you do that, you will get 8 only. So your x is a multiple of z, right? And they're saying x and y should not be a multiple of z. Since 1 is a multiple of z, so here it is not a valid z. So if it is not a valid z, let's say I want to try take 9. When you want to take 9, your x is 8, y is 5. The first condition will not be satisfied because the first condition says z should be less than equals to 8, z is 9, less than equals to 8 is false. Okay, one condition is false. Let's try to take the second condition. I mean, in this only second condition. So z is 9, y is 5. This is also not true. So first condition is not satisfying. So 9 will also be in, I mean, z taking 9 is not a valid GCND. So the element having I mean, z having more than these two is not a valid one. So that's why we'll have to take lesser. 8 we have taken, it is not valid because 8 is a multiple of 8. Let's try to take 7. When you take 7, what will happen is the first condition said z is less than equals to 8 and z is what, 7, less than equals to true. If even if 1 is true, then it is good. So if we don't need to check second, but let's check second also. Z is 5 here, so it is not holding. 1 is true, so that's why true. The second condition we need to check. Now let's try to find x into k1 is equal to z. X and y should not be a multiple of z, they have said, right? So okay, here the condition what I'm taking in a reverse way. X should not be a multiple of z, which means z into k1 is equal to 8. So this it should not be, this condition should not be holding. So let's try to take k1 x by z. Pardon me because in the previous example I wrote the other way. So here x is 8, z is 7. So you are not getting, it is not a perfectly divisible. So x condition is x is not a multiple of z. Now let's try to take k2, and which will give you as y by z. If you do it this way, you will getting this equation 5 by 7. This is also not a perfectly divisible. So now this condition holds good, this condition holds good. So z is equal to 7 is GCND of 8, 5. Since you have only one pair, so this is only the max possible answer, right? In this case your answer is 7. Let me take second example wherein you will have 3 elements and we'll try to find the pairs, and let's try to do it. I think you have understood, right? So in the first example, answer is 7. Let's try to take second example. We have 6, 6, 6. Just give me a second. So in the second example, n is 3 and elements are 6, 6, 6, right? So now in this case also, like as you can see, how many pairs you can make? 6, 6, 1 pair you can make. This is indexing 1 to 3 and this is 1, 2 indexed. Okay, the other one could be 1, 3 wala. So again it is 6, 6. the other one you can take 2, 3. 2, 3, and its elements are 6, 6. So all the pairs are same only in this case. Okay, if you want to find GCND of 6, 6, so all are having same only. So even if you find GCND of 1, it will be same. So let's find this GCND of 6, 6. Okay, now now z is equal to 7 you can't take, because this condition will not hold good, because whatever elements you're taking, this is x is 6, y is also 6, so the element should not be greater than both the elements, so we'll not be taking that. Let's say you're taking 6, 6 also you can't take, because 1, I mean in this case both the elements are multiple of 6, right? Here let's say we want to find k1, this is going to be x minus z, so 6 by 6, so 6 is perfectly divisible by 6, so this is not valid. Even if single is not, one element is not valid, so your z is not valid, but in this case both are not valid. So that's why whatever this the z value, I mean GCND you will be taking, it should not be equals to either this or this, it should not be equals to both. Yeah, so 6 is not a valid one. Let's try to take z is equal to 5, x you are having 6, y also you are having 6. So now let's try to take the first condition, wherein z less than equals to x or z less than equals to y. So it is 5, it is also 5, so both are correct, right? So 5 less than equals to 6 is true, so even if 1 is true, it is true. First condition hold good. Second condition, x should not be a multiple, so x by z if you are doing, x is 6, z is 5, so it is not perfectly divisible, right? You are getting some value like 1.2, so the point whatever you're getting, it is not a perfectly divisible, which means if you divide it you will get remainder 1, so it is not perfectly divisible. So yeah, first one is holding. Let's try to take second, y by z, so it is also 6 by 5, both are same only, that's why it is not a perfectly divisible. So this condition hold good, this condition hold good, so your z value 5 being it is the highest one, because you have 3 pairs out of which all are having same pair only, so even if you do GCD for all these 3 pairs, it will be same, so that's why 5 is the maximum answer in this case. So yeah, 5 is the maximum. Let's try to understand now this one. Here n is 4 and your elements are 8, 9, 8, 8. So now if you want to find the pairs, how many pairs you can find? First two you can find, this and this you want to find 8, 8 it will be, and you want to find this and this, it will be 8, 8 again. You want to find this and this, it will be 9, 8. You want to find this and this, and last one. So you have got if you could clearly see, you have got how many pairs? Different pairs. 8, 9, this is one of the pair. The second pair is 8, 8. 8, 8 is same only. 9, 8 also different pair you find, but the city of these two will be same only, right? So you will not be considering this. And then 9, 8 we have already taken, so 8, 9. So 2 pairs effectively you have got. So now let's try to find this D. Sorry, GCND. You have got 8, 8 as one of the pair and 8, 9 as other pair. So that's why I was saying since 9, 8 and 8, 9 both are same, that's why I'll be sorting this array, right? When you sort this, the elements are this way. So you'll get single pairs. You'll not be confused in a 8, 9 and 9, 8. So if you find as you saw in the previous example, these two elements are same. When these two elements are same, which means z is equal to more than this you can't take, equal to also you can't take, but lesser than that you can take. Lesser than that if you try to take 7, So first condition will also hold good, second condition will also hold good, because 8 by 7 is not a perfectly divisible, right? So for this case your answer is 7. Now let's try to find for this case what is the answer. Z will have to find, let's say x is 8, y is 9. So if this is the case, then let's try to as I said, you can't take z as 10 because it is greater than both 2, so first condition will not hold good. Let's try to take 9. If you try to take 9, your this condition will not hold good, because these two are same, so it is a multiple of each other, right? You can't take. Now if you want to take 8, this also you can't take, because this both are same, it will be a multiple. Now when you try to take 7, so first condition if you try to do z less than equals to x, 7 less than equals to 8 is true. Also z less than equals to y, 7 less than equals to 9 is also true. So first condition hold good. Second condition, you do x by z. X by z is basically 8 by 7, it is not perfectly divisible. Y by z if you do 9 by 7, this is also not perfectly divisible. So z is the maximum possible value here, 7, right, for this pair. And if you try to take 6, this will also be good, but you want maximum z, right? So for this pair also z is 7, for this pair also z is 7. So yeah, your answer for this case is 7 only. Now like this is a brute force way I was doing, right? Like I was taking all the pairs. Now now the thinking will come, like let's say you have taken elements as 7, 8, 10, 11. These 4 I've taken array element, and this 4. So when I've taken this, the pair possibles are multiple. You can take 7, 8. You can take 7, 10. These are unique pairs. Okay, again you can do 8, 10. You can do 8, 11. You can do 10, 11. Yeah, so 6 pairs we have got. So these are the pairs. Now if you try to find again GCND of all this, so it will be a brute force way. So now what I'll be doing is I'll be taking the lowest element and the highest element. I'll try to find the GCD of these two, 7, 11. I'll try to find. Why I'm doing this? Now question arises because what you want the maximum z. So if you want the maximum z, you will be taking the maximum number. Why you will be taking maximum number? Because you will find z according to the first one. What they've said is your the GC and the z value among x comma y, it should be lesser than at least one element. If it is lesser than at least one element, then your z is valid. So that's why I'll be taking the maximum number, and from maximum number, if I try to take the one less number, so and that number, if it is valid for both, I mean these two conditions, so that will be your maximum possible value, right? I think you're getting. So that will be maximum possible value. If I try with 10, so you can't take 10 only, you'll be taking starting with 9. But if you take 11, you'll starting with 10. So obviously 9 is lesser than 10, right? That's why I'll be taking the highest one. And why I'll be taking the lowest one is the question now. So lowest one, why I'm taking, because since only one number you want to be the z should be lesser than one number. It is not the way like it should be greater than other both numbers. So that's why the lowest number I'll be taking in such a way that it will satisfy for one condition. Like in this case x is 11 and y is 7, let's say. Okay, so if you're taken that, your z, let's say I'll start with 10. So and why I'm taking this as lowest, I'm telling here. So your k2 is going to be y by z, right? So when you're taking z as lowest and x as highest, so your z, you're trying to find basically somewhere in between x and y, right? Like x is the highest here, okay, and z should be lesser than x, and you are basically trying to find z in such a way that it is greater than y. This, if this holds good, then this will be the maximum possible value you are getting, or else you will be trying to find, in this way, equal to will not be there, because when both are elements as same, in that case, like we have seen 6, 6 case, 7, 8, 8 case, in that case both elements are same. So your z was one lesser than that, like 5. Here also one lesser than 7. That's why these both are equal, but your z should be small. So what I'm trying to say is that uh, the reason why I'm taking y as lesser is that y by z, y is if smaller than z, so that will not be perfectly divisible, right? Let's say y in this case is 7 and z is 10. So 10 cannot divide 7. So this condition will be holding good, and we are taking x as highest and 1 lesser than that when we are taking. So in that case k1 will be x by z, so 11 by 10. So this will not be also perfectly divisible by that. And as said in the question, x is greater than equals to 5. So no matter which element you're taking, like let's say x is 22. So when you take this z as 1 lesser than that, so this will 22 by 21 is not a perfectly divisible, right? So that's why. So always you try to take the highest one and the lowest one. When you try to take these two things, so your work will be done. Now when you take highest and lowest, what you are essentially will be doing is that, let's say in this case only you have taken 11 and 7. So if you take z as 10, so this is holding good, right? Like z is lesser than equals to x and z is lesser than equals to y. This condition is holding because z is 10 and x is 11. So one is holding good. So in this second, if you try to see, you do x by z. So as you saw, 11 by 10, so it is not a perfect divisible. Again same y by c, it is 7 by 10, it is also not a perfectly divisible. So 10 is your valid answer. So whenever you're taking highest element and lowest element, so if the difference between these two is greater than 1, like 11 minus 7, if you take this is 4, if it is greater than 1, your answer will be always highest minus 1, which is 10. Now the other case will be arising. In the previous example you have seen 8, 9, 8, 8 was there, right? 8, 9, 8, 8. So in this case highest is 9, low and lowest is 8. So in this case you can't take z as 8, because z 8 means it is equals to one element. If it is equals to 1, which means it will be a multiple of that. That's why in this case your answer was 7. So the difference when you take n minus 8, highest minus lowest, is giving you 1. So whenever the difference is 1, in that case your answer will be either highest minus 2 you can take, which is 7, or lowest minus 1 you can take, which is 7. So I think this is pretty much about the problem statement. You guys have understood. Basically take the highest one, lowest one, and then try to find the difference between them. If it is equals to 1, so your answer will be highest minus 2, or second highest lowest minus 1. Or else if the difference is more than 1, so in that case if it is more than 1, so in that case your answer will be always highest minus 1. If the difference is 0, which means the case wherein you have seen like 666, both highest and lowest were 66, so the difference is 0. If difference is 0, again in this case it will be answer was 5 only, so it is highest minus 1. So only the case wherein your difference is 1, in that case your answer is highest minus 2. In the rest other case your answer is highest minus 1. Think you guys have understood. Let's try to solve this. So we have test cases, we have n, so we'll be taking the elements, and as I said we need to sort this. Okay, now your lowest will be, since we are sorting in increasing order, lowest will be 0 and your highest will be n minus 1, right? Now what you need to do is, as I showed you, you'll have to find the highest minus lowest. If highest minus lowest is equals to 1, GCND. So your in that case your initially, like as I said, always your GCND will be highest minus 1, right? If highest minus lowest is 1, so in that case your GCND, as I said, it is highest minus 2, right? So yeah, now we'll have to print the GCND. So this was it about the problem statement. Not very tough, it was easy only. Basically you had to find the pairs and understand the problem, that's it. So let's try to submit in a code editor. So yeah, it got accepted. I think you guys understood. So I think you guys understood why I've taken highest and lowest, and you have understood the problem statement, like yeah, it is always highest minus 1 is the answer whenever highest and lowest have difference 1. So in that case your answer is highest minus 2. So yeah, if you have any doubts you can comment. If you have any doubts you can comment me. I'll try to help you out. Thank you guys for watching the video.